Table constraints. So far we've seen column constraints and constraining data on a column level. But then again, we are able to constrain multiple things. We are able to, for instance, create a primary key that has multiple columns. But how do we do that? Because we only have seen how we can do things at the column level. Well, that's where table constraints come into play. A table constraint is a definition that is not tied to a particular column, and it can encompass more than one column. It doesn't apply directly to a column. It's above that. It's at the table level, right? When you define a table, you're defining individual columns, but that table can also have checks against one or multiple of its columns. You don't need to define every constraint at the column level. It is useful when that column has specific constraints, and anytime that column has a specific constraint, you should do it at the column level because it's easier to read. But sometimes you may have multiple columns that need constraints. You may have other necessities that need to go into this, and that's where table constraints come into play. You see, when you apply table constraints, you can basically write any column constraint as a table constraint. And when we look at table constraints, well, we have pretty much the same constraints we did at the column level. We can make something unique. It can only contain unique values, and null is also unique. Remember that. We could set a primary key, but we could give a column list. So the main differentiation here is you can give a list of columns that need to adhere to this constraint. At the table level, it's a column list. It's not a specific column. And then when we write check conditions, check conditions are applied on inserting or updating. So you can check a condition against one or multiple columns. That's pretty good because a check constraint at the column level will check at insert or update at that column. But at the table level, you could check multiple things at the same time. So pretty useful. And then again, our foreign key references keyword that can reference another table. Extremely useful stuff here that you can write constraints in this way. Now, if we were to look at how we would write a table constraint, well, over here we can see our student table, and we can see that we had our UUID, and we're just giving it a default now. And we have our first name, last name. We're still giving the table constraints not null here at this level. But then here at the bottom, you can see I wrote the keyword constraint. And this is how you define a table level constraint. You're writing constraint at the bottom after all the columns are defined. And then you're giving that constraint a name so you can name it at this point. Postgres isn't going to name it for you. No, you're going to give it a name. So you have to have a naming convention. In this case, I chose PK for primary key, and then I gave it the column name that I'm applying the primary key to. And then I say, hey, here's a primary key, and here's my column list. In this case, the column list only contains one column, but you could do comma something else. So table constraints are very easy, very straightforward, very fluent in the way that you define them, because it's just a different way of defining your create table statement. And every column constraint can be written as a table constraint. Now let's go look at some of them. So over here, I'm in dbfiddle because it's an easy place to fiddle around with some concepts or show you guys some stuff. And you can see here, I've created a table called category, in which I've put a category ID and a type of type text and small int. I didn't use a UUID here because in dbfiddle, they do not have the plugin installed. Thus, giving a UUID type is a bit irrelevant. So we went with small int for this one. And then we created a table called column constraints, in which we'll define columns with a couple of column constraints. And we've created a table constraints, in which we'll take the same data, but we'll apply it as a table constraint. Pretty straightforward. So if we look at column constraints over here, we can see we have a column constraint ID. We have a column called something with text. And column constraint ID is a primary key. Something is text and not null. And then we've defined an email here. And now I've went ahead and created the check for this column. It is of type text and it has a check constraint. And what we're doing here is we're checking the value of email to match the following. And over here, you see this random mishmash of all these different types of characters and all these crazy kind of constraints. What is this? Well, this is what we would call a regex, or a regular expression. And regular expressions are a validation mechanism. They're basically a way to write down, hey, I only want things that match the alphabet A to Z. 0 to 9, they can contain a dot potentially and match the same value. For instance, if your email was mo.beanie@gmail.com or whatever the case may be, and then you can kind of constrain the input of text. It's basically a regular expression is to validate an input. That's what it's used for. When we look at regular expressions, they're a whole different language. They're implemented in a ton of different languages. They're implemented in SQL, you have them in JavaScript, in Python, in Java. They're something that crosses the realm of programming and databases because they're an easy and well-established way to do validation against text and input. When it comes to regex, we've compiled a list of resources and explanations and easy introductory level material that will help you get into regex and kind of learn about it. Now, we're not here to become regex masters, but it is an important skill. And so we've compiled what we find are some of the easiest, most comprehensive resources to get you into regex and to get you to understand how to apply regexes, because they are a useful validation input mechanism. And when it comes to data, what we want to do is we want to make sure that whatever we fill in here, that it adheres to certain rules. And if a regex is the way that we need to write those rules, well, we can learn how to write regexes and we can apply them. In this case, this regex I pulled from somewhere, and it's a simple validation mechanism that's gonna kind of validate a email address. And there are websites where we can test this visually. If you take regex 101, it is a website where you can go and you can copy a regex into place, and then you can go ahead and say, hey, if I type mo@beanie.io, what's going to happen? Well, it matches, so it's valid. And then if I, for instance, typed @beanie.io, so someone, for instance, went ahead and typed, hey, I'm going to not fill in the full thing. Well, it's not going to match, so we know this is going to error. But if I wrote an H here, okay, now we're valid. Now we're invalid. If I remove the @ now we're invalid. So you can see here how we're trying to validate the matching against this case. And you can see here, match a single character. So we're matching a single character set between A and Z, lowercase a and z, 0 and 9, and then match a character literal. So this will kind of go ahead and explain to you what all of these different parts mean, because it's kind of gibberish when you look at it, right? But I promise you, regexes aren't hard. You just need to go to the resources we've linked for you, read through it a bit, get familiar with the regex syntax. And once you're familiar with the regex syntax, it becomes very, very easy. And there are regexes all over the internet that can give you a starting place to kind of figure out how you want to apply checks. And this regex tester, regex 101, is a great place to go ahead and test out and see what your regex means. Now, with that said, what we've done here is we've applied this regex that's basically going to do an email validation, and we've just validated that it indeed checks emails. If you don't fill in a valid email, it's not going to match against what this says. So here we've also created a category ID with a small int, and it's referencing. So it's creating a foreign key to category, which is the upper table, category ID. So we have a foreign key transaction. And then here we have a create table where we're doing everything but with table constraints. So you can see we've done the same ID. We call it column constraints ID. We could have called it TC ID, but for all intents and purposes, we named it the same. We have something. We kept the column constraint on this one. And we have email where we removed the check. And then we have our category ID where we kept the foreign key. And what you can see at the bottom here is we've defined a constraint and we've named it primary key table constraints, and we've called it primary key of this. And then here we've done our constraint valid email where we check our email field against our regex. And so if we go ahead and run this, what we'll see is that there is a table constraint validation for valid email. And this is because over here you can see we're inserting into category and we're inserting proper category values. But when we insert into table constraints, we're doing a value, we're filling in a something, and we're giving an email. But the email is invalid, so we're hitting our constraint here. But if I made that Mo, well then suddenly we have proper constraints. And if we select it from table constraints here, then we will see that what's filled into our database is one something mo@beanie.io. And the same is true for column constraints. If we take column constraints and we removed the mo, we'll see that we're going to hit a column constraint against column constraint email check. So you see the difference in the name here? At column constraints, we defined it at the column level. So Postgres named it column constraints email check. But at the table level, we called it valid email. So it created a table constraint valid email. So it takes the name, right? At the end of the day, these constraints work the exact same way. But what you should remember here is that if you can define something that is at the column level, make it a column level constraint. But if it encompasses multiple values, make it a table level constraint. If it concerns multiple columns, for instance. So let's go ahead and fix this. And then let's select star from column constraints. And if we run this, what we're going to see is it allowed it to be filled in. Amazing. Column constraints and table constraints, although they are a different concept, they operate in the exact same fashion. It's just a different way of writing the same thing. And so you can decide which way you want to write it. But again, the best way that I found of applying constraints is if they're related to one column, write them at the column level. If they're related to multiple columns, write them as a table constraint. But make sure you have a proper naming convention in place so that your constraints are named the same every time you create a constraint on somewhere else. And so with all of that, let's jump into some exercises around creating tables.